So hi everyone. So the topic we're going to master today is differentiation note 2. Okay, so last time we did equation, and then previously we did the low D high, high D low, right? Okay, so basically today we'll focus on more advanced questions. That is point of inflection questions and also turning point questions. Okay, so in today's lesson you will master all the question types. Okay, and also master gradient increasing or decreasing function questions. Okay, and then finally we'll move on to the IB exam drill. Okay, so first page, turning point. Okay, so what does it mean by turning point? So we all know that turning point, okay, is actually there's a turning, right? Okay, so it means that is maximum or minimum. Okay, so turning point can be either maximum or minimum. Why is that? Because there's a turning point, okay, like this, right? Okay, so going up and then turn down, right? Okay, so this one going down and it goes up, right? So that's why this is what we call a turning point. Okay, so that's why it can be maximum or minimum. Okay, but whenever you see this word, okay, and then you always think of, okay, the slope for maximum or minimum must always be what? Must always be 0 at this point. Okay, f dash x is the gradient, right? Okay, so f dash x is 0 for maximum or minimum. Okay, the gradient is 0. Okay, and then but sometimes the question word would say that the horizontal tangent of the graph, okay, that would touch the point, okay, and that point it will be the turning point as well. Okay, why is that? So basically very easy. So if I draw a random graph, okay, like that. So if you have a horizontal tangent that would touch a point, okay, then it must be a horizontal line touching a point, and that point must be a maximum, right? Okay, and if you draw a horizontal line like this, okay, and this point must be a minimum. Okay, so it can be either a maximum or minimum. Okay, so basically that's the concept. Okay, or sometimes they will change the wording to tangent parallel to x-axis. Okay, if that point, okay, is being touched by the parallel tangent to x-axis, so tangent parallel to x-axis, it means horizontal tangent, so they are the same. Okay, so whenever you see this, always think of f dash x equals 0. Okay, yeah, so that's the key concept. Okay, so let's look at the questions. So sample question right here. So fx equals to x cubed minus 12x plus 2. Okay, the tangent to the curve at the point P and Q, they are parallel to x-axis, right? Okay, so parallel to x-axis, it means that it must be f dash x must be equal to 0, right? Okay, so calculate the coordinates of P and Q. So very easy. So f dash x equals to 3x squared minus 12, right? Differentiation, and then you make it equal 0. So finally you have 3x squared equals 12, x squared equals to 4, x is equal to plus or minus 2, right? Okay, but coordinates, P and Q, right? Okay, so whenever you see coordinates, you have to find the y as well. Okay, so I have to sub it into the original to find a point, right? So sub in 2 into the original, not into the f dash x. Okay, f dash x is a slope, right? Okay, so f dash x, I know that is equal to 0 at the maximum or minimum point, right? Okay, but for this one you have to calculate the coordinates. So sub in 2 cubed minus 12 times 2 plus 2, right? Okay, and then just use calculators. So I have low battery. Okay, so 2 cubed minus 12 times 2 plus 2, right? Okay, minus 14. And then f minus 2, then what do you get? So minus 2 cubed minus 12 times minus 2 plus 2, right? So that is equal to minus 2 cubed, right? Minus 12 times minus 2, and then plus 2, yeah? So it's 18. Okay, so the coordinate is 2 minus 14 or minus 2, 18. Okay, but if the question asks you, oh, which one is the maximum point? Okay, so actually you can find this out because 2 minus 14 is right here, and then minus 2, 18 is right here. So obviously this point is the maximum, right? And then this point is the minimum. Okay, but the question here doesn't say that P is to the left of Q. So which point is P, which point is Q, right? Okay, it doesn't mention. So that's why you just need to find out 2 minus 14 and then minus 12, 18. That's the coordinates. Yeah. Okay, so that's the main concept, parallel to x-axis, tangent. Okay, f dash x equals 0. So next page. Practice question 1 and practice question 2 as well. Okay, So this one I'll let you try. So you can have 40 seconds, okay? Question 1. Okay, so fx equal to this, right? Horizontal tangent touch the graph at point P. Okay, horizontal tangent, it means f dash x equals 0 because the slope must be equal to 0, right? Okay, so f dash x equals to 6x plus 4, okay, equals 0, and then x is equal to minus 4 over 6, which is minus 2 over 3, okay? And then you have to find a point. Point means xy, so sub in x into the original equation. 3 and then minus 2 over 3 squared plus 4 times minus 2 over 3 minus 1. Okay, so GDC. So 3 times negative 2 over 3 and then square plus 4 times negative 2 over 3 minus 1, right? Okay, then you have this answer. So, or you can change it to fraction, minus 7 over 3. Okay, so that's the point. So minus 2 over 3 minus 7 over 3. Okay, so very easy. And next page, question 2. Quotient rule. Okay, so the graph has the minimum point. Find the minimum point. Okay, so I'll let you try. So minimum f dash x must be the slope at that point must be equal to 0. So f dash x must be equal to 0, right? Okay, so quotient rule. Do you still remember that? So low d high minus high d low over low square. Okay, when you differentiate ln x on the data booklet, you have 1 over x. Okay, try this. So you can have 50 seconds. Okay. Okay, so basically f dash x, okay, f dash x low d high, right, minus high d low, okay, over low square, right? Okay, so it's ln x minus 1 over ln x square, right? Okay, and then you make this equal 0. So multiply this, okay, 0 multiply anything, it will be just 0. So ln x minus 1 equals 0, right? Okay, so ln x equals to 1. Okay, how do you solve the x right here? So if you still remember the log, okay, then you can just add what at the bottom. Eliminate the ln. So we have to raise this to the power e, right? Same constant, same base. Because when you have log 4, 5, okay, when I add 4 at the bottom, then you can cancel this out, right? Okay, same thing. ln is log to the base e, okay? So if you forget about this, then I recommend you to go over the log note, okay, or my video again, okay? So log note 1a, okay? So basically e ln, okay, cancels out, very easy, special skill, right? Okay, x and then equals to e, okay? But find a point, so you have to find xy. So that is f e equals to e over ln e. Ln e is equal to 1, right? So just e. Why ln e is equal to 1? Because log e, which is equal to 1, right? Because that is power 1 right here. Cancel this out, it's 1. Okay, log calculates the power, right? Okay, e to the power 1 equals to this, yeah? Okay, ln e is equal to 1, okay? So that is equal to e. So the point is e, okay? Next page. So next page, increasing or decreasing function, okay? So whenever you see increasing function, it means that f dash x, the slope must be positive, okay? Decreasing function, f dash x must be smaller than 0, okay? Because going up and then going down, right? Okay, going down, the slope going down, okay? So for this one going up, yeah? So whenever you see this, okay, always think of f dash x bigger than 0, increasing function, okay? So f dash x, so I've already mentioned right here, okay? And then decreasing function, f dash x smaller than 0. So let me draw a graph right now. So let's say this one is point x equals 3. So before x equals 3, okay, is always going up, right? So that is f dash x must be bigger than 0, okay? And then at this point 0, and then at this point f dash x is smaller than 0, okay? So going up 0 and then going down. So the y-axis here is fx and this is x, okay? So the sample question here, so fx equals to 4x squared plus 5x minus 1. Find the possible values for x, okay? For fx is increasing. So whenever you see this word, always think of f dash x bigger than 0, right? Okay, so f dash x is equal to 8x plus 5, and then I know that the whole thing must be bigger than 0, right? So 8x equals to bigger than minus 5, and then x is bigger than minus 5 over 8. So that's the possible values, okay? That's all the values. So that will be just minus 5 over 8, okay? So next page, this one, okay? So question 1, you can have 30 seconds to try. Okay, so differentiation, okay? So differentiate smaller than 0, right? Minus 10x plus 4 smaller than 0, okay? Minus 10x minus 4, okay, whenever you divide or multiply negative numbers, so you have to swap the sign, right? Okay, swap this, change the direction, so that would be x bigger than 4 over 10, yeah? So that is 2 over 5, okay? So x is bigger than 2 over 5, that's it. Okay, next page. So practice question again. So this time is ex, okay? So whenever you differentiate ex, it's the same thing, right? It's ex, yeah? So you can have 30 seconds, okay, to try this out. So, but this time explain why it is a decreasing function, okay? So I'll let you try first. Okay. So decreasing function, right? Okay, so f dash x, it will be equal to minus 4e minus 4x, okay? Why is it? Because when you differentiate ex, we keep the same thing and differentiate the power, that is minus 4, okay? So why is it, for this time you may add smaller than 0, okay? But actually this one, okay, explain why, okay? You have to explain why is it decreasing, okay? So actually when you have this, okay, and then I know that no matter what we sub in for x, okay, this part, so let's say e negative 4 times, when you sub in 1, okay, you won't have a negative number, it's always positive. Negative 4, right? You have a positive number, okay? So when you sub in 0 into this, okay, then you have 1, right? Because e power 1. If you sub in negative number, let's say negative 1, so you have e power 4, obviously is positive, right? So it's positive value again. So it's all positive. Impossible to get any value that is negative, okay, if you sub in x into here, right? And there's positive multiplied with negative, then that's why the whole thing, the differentiation must be smaller than 0, okay? But how do you explain it in words? So this one's like 2 more questions, okay? So if I ask you why this is decreasing function, when you differentiate that, and then you can just say, because the f dash x is smaller than 0 for xer, okay? So no matter what you sub in, okay, whatever number, right? Okay, so x is the elements of real numbers, right? Okay, smaller than 0, right? Okay, so that's why. So the function is decreasing. That's it. That's how you explain. Okay, so first you differentiate and then you prove why is it decreasing. Okay, but in the exam you don't need to write the steps. Okay, so you just need to write this 2 sentences. Okay, and also differentiation. Okay, so next page, point of inflection. So point of inflection is more important. Okay, so f dash x, we know that is gradient. Okay, gradient, right? But f dash x, okay, helps you to find out what. Okay, so if gradient is positive, I know that it's going up, right? If negative, then the graph is going down, right? Okay, but for f dash x, okay, so basically if that is positive value and this one is negative, then what do you get? This one is either smile face or sad face. So second derivative determine the curve, okay, is a smile face or sad face. Okay, if that is a positive value, then it must be a smile face. Okay, and if that is a negative value, then it will be a sad face. Okay, and point of inflection, okay, is what we call when the second derivative equals 0. Okay, because I know that when second derivative is positive, it must be a smile face. Okay, and then after that it will be a sad face. Okay, and between the 2 points, this point is what we call neutral. Okay, the f dash x equals 0. Okay, so there's no emotion, okay, for the point of inflection, POI. Okay, for this one, happy face, I know it's a plus. Okay, sad face is a minus, right? Okay, so and in the middle, then there's no, okay, emotion, right? Okay, so point of inflection, another name for that is, okay, no emotion. Okay, so basically f dash x equals 0. That's all you need to know. Yeah. Okay, so let's look at the question and then you'll understand what I'm talking about. Okay, so sample question right here. So fx equals to x cubed minus 6x squared plus 12x minus 5, right? Okay, find the point of inflection. Okay, so always second differentiation equal to 0, right? Because point of inflection. Yeah, so differentiate all this, then you have 3x squared minus 12x and then plus 12 equals 0, right? And then you solve this. Okay, so how do you solve this? So you just factorize, right? Okay, so 3x and then x and then 12, that will be just 4 and then 3, 4, 6, 6, 2. Yeah, 6 and 2. Okay, minus, right? Okay, then you can see it's 3x minus 6 and then x minus 2. You do the cross method, okay, equals 0. Then you can have the 2 points. So x is equal to 6 over 3 or x is equal to 2, right? Which is also 2 right here. Okay, so basically we only have 1 point. So you can see point of inflection, that is x equals 2. Okay, but point, you have to find xy, right? So I have to find a y as well. So sub it into original. f2 equals to 2 cubed minus 6 times 2 squared and then plus 12 times 2 minus 5, right? Okay, so just use calculator. 2 cubed and then minus 6 times 2 squared and then plus 12 times 2 minus 5, right? Then you get 3. Okay, so the answer is 2, 3 is the point of inflection. Okay, so that's how you find the point of inflection. Usually 3 marks in the question. Okay, so next.